Amazing morning. So let's have the quarter 1, week 4, lesson 6. It's all about geometric sequence. How do I define a geometric sequence, and how do I use the formula to find the different terms of the sequence? At the end of the lesson, the learners are expected to familiarize themselves about the formula in finding the nth term of a geometric sequence. 2. Insert geometric means in the given geometric sequence. 3. Solve for the nth term of the geometric sequence and realize the value of geometric sequence concepts in solving real-life problems. Geometric sequence is a sequence where each term after the first term is obtained by multiplying the preceding term by a non-zero constant called the common ratio. So for us to get the nth term, we are going to use the formula a sub n equals a sub 1 times the common ratio raised to the number of terms, where a sub n is your nth term, a sub 1 is your first term, your n is the number of terms, and r is the common ratio. Okay, let's find the missing term. So let's have number 1. So number 1, we have 3, 12, 48. Now, so for us to get the common ratio, so we have 12 divided by 3. Now, so 12 divided by 3 is 4. So our common ratio for number 1 is 4. So we need to multiply 48 by 4. So 48 times 4 is 192. Times 4 is 768. Now, so let's have number 2. For the common ratio of number 2, we're going to use 64 and 32. So 64 divided by 32. So 64 divided by 32, so the common ratio is 2. So 32 divided by 2 is 16. Divided by 2 is 8. Na? So let's have number 3. So number 3, we have 120, 60, 30. So we're going to use 60 and 120. So 60 divided by 120 is equal to 1/2. No? So our common ratio is 1/2. So 30 divided by 2, we have 15. Divided by 2, we have 7.5. Divided by 2, we have 3.75. Na? So let's have number 4. Number 4, we're going to use 20 and 40. So common ratio is equal to 40 divided by 20. 40 divided by 20, we have 2. So 5 times 2, 10. Times 2, 20. Times 2, 40. Times 2, 80. Times 2, 160. Na? So let's have number 5. Number 5, we're going to use 36 and 12. So common ratio is equal to 36 divided by 12. So the answer in here is 3. Na? So we're going to have in here 4/3. 36 times 3, 108. Times 3, 324. Na? So let's have number 6. Number 6, we have, we're going to use 36 and negative, we're going to use negative 32 and negative 16. So common ratio is equal to negative 32 divided by negative 16, which is a positive 2. No? Negative 2 times 2 is negative 4. Times 2, negative 8. Times 2, negative 16. Times 2, negative 32. Then times 2, negative 60. Okay, so let's have number 7. For number 7, we're going to use negative 32 and 16. So 16 divided by negative 32. So the answer in here is negative 1/2. 256 divided by negative 2 is negative 100. 28 divided by 2, negative 2, we're going to have 64. Okay, let's have number 8. So, number 8, no? So, obviously, your common ratio in here is 1/3. So, 27 divided by 3, 9. Divided by 3, 3. Divided by 3 is 1. Okay. In here, we still need to have 1 in here to insert, no? For us to have 1/3. Okay. Number 9, we're going to have there 256 divided by 64, no? Which will give you 4. Okay? So, 1/4 times 4 is 1, times 4 is 4, times 4 is 16, times 4, 64, times 4, 256, na? So, for number 10, your common ratio in here will be 5x to the 8th over 5x to the 6th, which will give you x squared. So, x squared, no? 5x squared times x squared is 5x to the 4th. 5x to the 8th power times x squared is 5x to the 10th power. Okay, so we need to insert 3 terms between 2 and 32 of a geometric sequence. So, let's have first the given. So, we have 2 and 32 is the last term. So, we need to insert 3 terms. So, we're going to use, no, the first term, which is 2. How many terms do we have? 1, 2, 3, 4, 5. So, we have 5. The last term, which is the 5th term, or a sub 5, is 32. And then, we're going to use the formula. The nth term is equal to the first term times the common ratio raised to the number of terms minus 1. And then, we're going to substitute na with the given. So, we have 32 equals to common ratio that we don't know, 5 minus 1. Okay? Divide both sides by 2. So, we're going to have 16 is equal to common ratio. 5 minus 1 is 4. And then, we're going to get the fourth root, no? Then, the fourth root of 16 is 2. Positive, negative. No? So, we're going to have 2. No? Let's have first the positive 2. So, we're going to have 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So, if we're going to use the ratio that is a negative, 2 times negative 2 is negative 4, times negative 2 is 8, times negative 2 is negative 16, times negative 2 is 32. So, we have 2 solutions. Geometric means. So, inserting a certain number of terms between 2 given terms of geometric sequence is an interesting activity between any activity in studying geometric sequences. So, we call the terms between any 2 given terms of geometric sequence as geometric means. First and the last terms of a geometric sequence are given. The terms between them are called the geometric means. For example, the 3 geometric means of the geometric sequence 2, 6, 18, 54, 162 are 6, 18, and 54. To solve the geometric means of a geometric sequence, the formula for the nth term of the geometric sequence is also used. To solve, no? So, we're going to have a sub n equals a sub 1 times the common ratio raised to the n power minus 1, where n is the number of terms, or the term number, and the first term, or a sub 1, no? Then let's use the geometric sequence, no? 4, 8, 16, 32, 64. For instance, the only given in the problem are the first term and the last term. So we have 4, 64, no? 4, then the 3 geometric means, and then we have 64 as the last term. So how can we solve the geometric? First, no, we need to have step 1, find the common ratio. No? Let's have the last term, which is 64, equals the first term, that is 4. Then let's have the common ratio that we don't know, so we're going to use R. Then the number of terms, that is 5 minus 1. Na? So we need to substitute the first term, the last term, and the number of terms. And then we're going to simplify the exponent. So 5 minus 1 is equal to 4. Okay? And then we're going to divide both sides by 4. So 64 divided by 4 is 16. 4 divided by 4 is 1. R to the 4th power. So 16 is equal to the R to the 4th power. And then we're going to use the 4th root. Na? Okay? So the 4th root of 16 is a positive and a negative 2. Then let's have the step 2. Multiply the first term with the common ratio, R is equal to 2, to get the second term. Then repeat the process until you solve the 3 geometric means. So we're going to use, if we're going to use the negative 2, we're going to have another solution as well. Okay? So for us to get the second term, 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is equal to 32. If we're going to get the so the next 3 terms, or the geometric means using common ratio, that is a negative 2. So it will be times negative 2, no? So it will be negative 8 times negative 2 is 16 times negative 2 is negative 32. So the 3 geometric means are 8, 16, 32, and negative 8, 16, and 32. Negative 32. Okay, let's have the activity wherein we're going to translate the word I love you very much in French by determining and matching the common ratio or the common difference of the following, and then placing each letter on the spaces below the decoder. No? So let's have the first one. So we have 1, 4, 7, and 10. It is obviously a common arithmetic sequence. So we're just going to have the common difference, which is 4 minus 1, which is 3. So you will write, no, on the first box, no, this code, and then the other one we have 1, 4, 16, and 64. So this is a geometric sequence, so we're going to get the common ratio, that is 4 over 1. 4 divided by 1, which is 4, no? And then the code EA will be placed on the 1, 2, 3, 4, 5 on the 5th box, which is common ratio is equal to 4. So that's how are you going. Okay, so let's have the next activity wherein we need to find the 10th term of the geometric progression. So in here, I will just give you 2 examples, no? Okay, let's have number 1. We have 420, 100, and so on. So let's have first the given. So let's have a sub 1, which is 4. Number of terms, we need to have the 10th term, so number of terms is 10. And then the common ratio is equal to 20 divided by 4, which is 5. No? So let's have the formula. A sub n equals a sub 1 times the common ratio raised to the number of terms minus 1. No? So we're going to have a sub 10. Your first term is 4 times the common ratio, that is 5. Number of terms is 10 minus 1. So, we're going to have 4 times the common ratio. 10 minus 1 is 9. So, that will be the 5 raised to the 9th power is 1,953,125 times 4. So, your final answer must be 7,812,500. Okay, so that is your 10th term. And then, let's take number 3. No? Your a sub 1 is 2. Number of terms is 10. The common ratio is 6 divided by negative 2, which is negative 3. No? So, we're going to use the formula a sub n, or n term is equal to the first term times the times the common ratio raised to the number of terms minus 1. So, a sub 10 is equal to the first term, that is 2, the common ratio, that is negative 3, the number of terms, that is 10 minus 1. 10 minus 1 is 9. Negative 3 to the 9th power is, this is a negative, this is a negative as well, right? Negative. Okay, is negative 19,683. Okay, then we're just going to have the 10th term. So, times 2 will be 39,366. So, that will serve as your 10th term. The learning task 3 tells something about what you have learned by answering the following questions. So, explain how to determine the next term of the geometric sequence 3, 6, 12, 24. No? Then, let's have number 2. In your opinion, where can you apply the concepts and skills that you've learned about geometric sequences? Explain. Okay, so we need to find the indicated number of geometric means between each pair of numbers. So, the first one that we have is 16 and 81. We need to insert 3 terms, no? So, let's have the given first. So, your a sub 1 is 16. The number of terms is 5. And the last term that you will use is 81. Now, we're going to use the formula a sub n, or the n term, is equal to the first term times the common ratio raised to the number of terms minus 1. And then we're going to substitute. So, we're going to substitute the given. So, we have 81, 16 times the common ratio that we don't know, 5 minus 1. So, we're going to have in here 81 is equal to 16 r to the 4th power. So, 5 minus 1, no? Divide both sides by 16. No? So, we're going to have r to the 4th power, or the common ratio raised to the 4th power, and then 81 over 16. Then, let's get the 4th root, no? 4th root. So, your common ratio, no, 4th root of 81 is 3. And the 4th root of 16 is 2. So, our common ratio is 3 over 2. Okay, so 16 times 3 divided by 2 is 24. 24 times 3 divided by 2 is 36. 36 times 3 divided by 2, so we have 54. So, those are the geometric means of number 1. For number 2, we need to insert 3 geometric means, no, between 256 and 1. So your first term is 256. So number of terms is 5. Your last term is 1. So a sub n equals a sub 1 times the common ratio raised to the number of terms minus 1. So 1 is equal to 256 times the common ratio, then the number of terms is 5 minus 1. So we're going to divide both sides by 256, then r to the 4th power. Then we're going to get the 4th root, no? The 4th root of 256 is 4. So your common ratio is 1/4. No? So we're just going to divide 256 by 4. 256 divided by 4, 64. Divided by 4, 16. Divided by 4 is 4. Divided by 4 is 1. So our geometric means are 64, 16, and 4. For number 3, your first term is negative 32. Number of terms is 4. And then the last term is 4. No? So, a sub n, or the n term, is equal to the first term times the common ratio raised to the number of terms minus 1. No? So, it will be 4, negative 32, common ratio that we don't know, and then 4 minus 1. So, 4 divided by negative 32 equals to 4 minus 1 is r cubed. No? And then, the lowest term of 4 and negative 32 is negative 1/8, which is your r cubed. No? Then get the cube root. So we're going to have in here negative 1/2. Okay? Negative 1/2. So if we have the negative 1/2, no? So we're going to have negative 32, 16, and negative 8. By the way, if we're going to use in here for number 2, the negative 1/4, because we're going to have negative positive. So, another thing in here, 256, negative 64, 16, negative 4, and 1. No? Another solution for that. And in here, it will be a positive, negative, no? If we're going to use the negative 1, okay, it will be 16, negative 24, 36, negative 54, and 81. Okay. Another solution for that. No? Let's have number 4. So for number 4, your first term, no? Your first term is 1/3. Number of terms is 3. So a sub 3 is equal to 64/3. Okay. So it will be 64/3, 1/3, then 3 minus 1 is 2. No? Then, going to divide 1/3 with 64/3, it will be 64/3 times the reciprocal of 1/3, which is 3/1. So it will be 64 r squared. No? So square root of 64, and that is 8. Positive, negative 8. No? If we're going to take the positive, no, this will be 8/3. If we're going to take the negative 8, it will be 1/3, negative 8/3, and then 64/3. So geometric means are positive 8 over 3 and negative 8 over 3. Okay? Now, let's have number 5. For number 5, no, your first term is 2xy. Number of terms is 4. The last term is 16xy. Okay, so we're going to substitute these things. 16xy is equal to 2xy. Common ratio, number of terms is 4 minus 1. Divide both sides by 2xy. So this will be 8. Na? Then you're going to have our cube. Cube root of 8 is 2. No? So the next terms, no, for 2xy, so we have 2xy times 2, 4xy times 2, 8xy. Na? So the geometric means for number 5 are 4xy and 8xy.